Hi, I'm Prabhu, instructor at LeadPix, and today we're going to learn manual transmission and gear shifting principles. All road vehicles powered by internal combustion engines have a transmission as a part of the powertrain. It's what moves the power from the engine to the wheels and help control a car's speed and torque. Cars are continuously evolving, improving, and becoming more efficient. That goes for the transmission as well. There are two basic types of transmissions in use: manual and automatic, which can be further extended to automated manual transmission system, also known as AMT, continuously variable transmission system, also known as CVT, and so on, each geared toward specific needs and driving styles. There are two basic questions in our mind. What exactly is the transmission and what role does it play? In simple words, transmission is used to transmit engine torque to driving wheels to drive the vehicle on the road. Usually, a transmission system consists of a gearbox plus a differential. The gearbox contains all the gear assemblies, shafts, synchronizers, rails, etc., which we are going to discuss in this video later. The role of a transmission is to adapt the torque output of the engine function of the road load, make possible the backwards movement of the vehicle for the same direction of rotation of the engine, allow engine disconnection from the rest of the powertrain. In this video, we'll give you a conceptual introduction on the workings of an actual transmission with some key concepts like clutch operation, gear ratio, torque, etc. The manual transmission is the original type of transmission. It's also called the standard transmission, but there's a good chance you'll know it as the stick shift. This type of transmission has the driver using a clutch to control the torque transfer from the engine to the transmission, manually shifting between gears as necessary. Most drivers feel they're more involved with the mechanics of the vehicle and that it's simply more fun to drive. The power generated by the engine flows through the transmission before it reaches the drive wheels. The basic function of the transmission is to control the speed of the torque available to drive wheels for different driving conditions. For example, if you want to climb a hill, you need more torque. By reducing the speed at the transmission, we will be able to achieve higher torque for the same power input, where power equals to torque multiplied by speed. Conversely, if the torque demand is low, we can increase the transmission speed. Let's deep dive into inner working principles of manual transmission. There are two different types of vehicles: front-wheel drive and rear-wheel drives. We will create a separate video to know the exact difference, but both require transmission with some minor differences. For now, we will focus on rear-wheel drive vehicles. In every rear-wheel drive combustion engine vehicle, we find the following parts: the engine, clutch, transmission, drive shaft, differential, axle, and wheels. The front axle usually contains the engine and gearbox, while the rear axle contains the differential. The engine combusts fuel, which moves the piston and crankshaft, creating rotation. The clutch engages or disengages the engine's rotational energy to the transmission. The transmission contains a number of gears which transfer the speed of the engine towards the wheel and enables us to change the speed and torque of the vehicle. The shaft transfers the power to the rear differential. The rear differential distributes its power to the wheels, causing them to rotate and propel the car. Manual transmission requires the driver to know exactly when to change a gear, which gear to change to, and also operate a clutch to disengage and re-engage the engine. We start the car in the lowest gear and increase the gear as the vehicle increases in speed. Then we change down as we drive uphill. Let's understand the gear principle with the help of bicycle and gear ratio. A lower gear provides low speed but high torque. A high gear gives high speed but low torque. Torque is a measurement of the force which causes something to rotate around the point or axis. Manual transmissions work on the simple principle of gear ratio. If we were to connect two gears and rotate one of them, then the other gear would also rotate. If we attach the engine to the first gear, then this will be the driver gear, and the other gear is therefore the driven gear. When the two gears are the same diameter, we have a 1-to-1 ratio, which means every time the driver gear completes a full rotation, the driven gear also completes one rotation. So, the out speed is the same as the input speed. If the driven gear is twice the diameter of the driver gear, then we have a 2-to-1 ratio, which means for every one full rotation of the driver gear, the driven gear rotates only half a turn. So we need the driver gear to rotate twice to complete a full rotation of the driven gear. Notice that the driven gear rotates the opposite way. This is basically a reverse gear in order to make the output rotate in the same direction as the input. We need to insert another gear which creates something known as a gear train. The middle gear is known as an idler gear, which could add many gears side by side to change the speed as well as output direction. Let's understand the basic transmission. First of all, we have the main housing, which will protect all the internal components and hold them in place. The transmission housing contains 3 shafts interacting with one another. The input shaft is attached to the engine, the output shaft to the differential, and the third shaft, also called the lay shaft or the counter shaft, interacts with the other two via a system of gears. The number of input gears are fixed to the counter shaft. These will therefore all rotate together. On the input shaft, we also have a gear which is in constant mesh with a counter shaft. The gear teeth are at an angle which is known as a helical cut. On the other end of the input shaft is a clutch. This will connect to the engine and drive the input shaft. The purpose of the clutch is to decouple the engine from the transmission. Anytime the clutch is engaged with the engine, it causes the input and counter shaft to rotate. There are also a number of different sizes of gears on the output shaft in a constant mesh with the gear in the counter shaft. There is a twist. The output gears are loosely connected to the output shaft. If we connect only one gear to the shaft at a time, the shaft will have the speed of the connected gear. With the help of a hypothetical connector, different gear ratios are illustrated here. Gears are used to change torque. Gear ratios of greater than 1/1 are reductions in speed and gains in torque. Gear ratios of exactly 1/1 are direct drives with no change in torque or speed. Gear ratios of less than 1/1 are overdrives or increases in speed and loss in torque. It's interesting to note that in the fourth gear, the input and the output shafts are directly connected. The art of loosely held gear to the shaft effectively and smoothly lies at the heart of the manual transmission. Let's see how this is done in actual practice. First of all, the main shaft gears have a synchronizer cone teeth arrangement. A hub is fixed to the shaft. A sleeve that is free to slide over the hub is also used in this system. It's clear that if the sleeve gets connected with the teeth of the synchronizer cone, the gear and shaft will turn together, or the desired locking action will be achieved. But during the gearbox operation, the shaft and gear will be rotating at different speeds, so such a locking action is not an easy task. A synchronizer ring helps to match the speed of the gear with that of the shaft. The synchronizer ring can rotate along with the hub as well as free to slide axially. Before moving the sleeve, the clutch pedal is pressed this way, and power flow to the gear is discontinued. When we move the sleeve will press the synchronizer ring against the cone. Due to the high frictional force between the synchronizer ring and cone, the speed of the gear will become the same as the shaft. At this time, the sleeve can be slated further and it will get locked with the gear. Thus, the gear gets locked with the shaft in an efficient and smooth way. The same mechanism is employed to shift other gears, such as first gear, second gear, third gear, and fourth gear. Now let's see how the reverse gear works. The reverse gear uses a 3-gear arrangement as shown. Out of those, one is the idle gear. When the idle gear is pushed and connected to the other 2 gears, the output shaft will turn in the reverse direction. Please note here that the reverse gear does not have a synchronizer ring mechanism. This means that the gearbox rotation must stop completely before applying the reverse gear. The next part of this series will briefly explain the clutch mechanism, which is an important part of the manual transmission.